Alright, so we're going to do lesson 1, and if we can, I want to get lesson 2 out of the way, because there's only 2 slides, so we can wrap that up. If we get through all of that today, then we won't have a lesson tomorrow. You can just work on your assignments, especially because there's 4 for lesson 1 and 2, okay? So we've done all of the fluency. Hey, here's an equation, solve it. Here's an inequality, solve it. Now we're taking all of those skills and then applying it to context. So we're going to have to read and analyze information in order to identify what we need to answer a question, or be able to write an equation that models a scenario, okay? Or even recognizing that you can answer multiple questions with the same model from the same scenario. So we'll have a couple things that repeat. This first context we'll see for the next few examples, all different types of questions that you'll see. So in 2014, County X had 783 miles of paved road. Starting in 2015, the county has been building 8 miles of new paved road each year. At this rate, if N is the number of years after 2014, which of the following functions, F, gives the number of miles of paved road there will be in County X. Now, what's really important is identifying first and foremost what your variables mean, okay? So based on that reading, what does N mean? Years after 2014. So it's years, all right, after 2014. And then F of N represents what?
So 8 new miles.
I don't want any numbers. I just want to know, what does F of N mean? Just F of N.
Number of miles.
Miles of paved road. Miles of road. Okay? So N is years. F of N is roads. Okay, miles of roads. So when we're writing an equation, we need to consider all that information. And when we're answering different questions, again, we need to consider that information. What does N mean? Not just what's the value, what's the solution. I mean, what does it mean? What does F of N mean? Okay, what are those different values? So now we need to look at those equations and we need to figure out, well, which one is going to be the best model for that situation. Does anyone want to take a guess at which of those equations might be the best model for that scenario? Well, that's a good starting point.
That's the only one I know.
We can use that as an outline because we know these are all linear models. So we can use the concepts of slope and intercept to identify which of those would be the best one. Take a good guess then. Which one? Yeah, which one do you think it is?
I don't want to look dumb for the whole class. I'm going to say A.
Why do you think A?
I don't know, because there was already 783 miles of road.
Mm-hmm.
So,
Okay.
oh, never mind. All right.
You want to change it?
Yeah.
Okay. What do you want to change it to?
C, because it's not really going to change. It's already there.
Okay.
So it shouldn't change. So anything added, like anything, like that's going to be added.
Yeah. So working through that thought process helped you kind of adjust it, right? Because you said, okay, 783 is already set. That's not going to change, right? Well, 783 for this one would change every time I increase the value of N. So I know it's not going to be that. I know it's not going to be that. Okay? So we've got 783 is already set in stone. Okay? If we want to use our linear equation as our model, 783 is our starting point, which a lot of times in linear equations we refer to as the y-intercept. Our y-intercept is often our starting point. That's what our constant would represent. It's constant. It does not change. That's why it's called a constant. All right? So 783 is constant. It's there. It's not going to change. And so that's the only equation that has a constant of 783. So y equals something x plus 783. In our linear equation, what is m? Slope. Slope is rate of change. How much it changes. 8 miles per year. Each year. So m is slope. Slope is rate of change. So ask yourself, how much is it changing? And words like each, per, every, those are things that represent change over time. 8 years, or 8 miles per year. So we can see that if we switch these two terms around, we end up with our function c. So rate of change as well as our y-intercept, that constant value. Okay? That's what we're going to be using when we're trying to write linear models that match these different scenarios. Now we're going to use the same function, f of n equals 783 plus 8n. That's the function we chose that models the scenario. But now we're going to look at a couple different perspectives of that same model. So we still have the 783 miles, 8 miles of new paved road each year. Here's the new part. At this rate, how many miles of paved road will County X have in 2030? So the first thing you need to identify is, what are you solving for? We have a variable that represents miles, and we have a variable that represents time. Are we solving for miles, or are we solving for time? Miles. So that's what it says. How many miles? How many miles? Which variable represents miles? Is it f of n, or is it n? F of n. That's what I need to solve for. And if I'm solving for miles, that means somewhere in here they give me something to plug in for n. So I need to solve for f of n, but they've given me something for n. Okay? They've given me a number to use. What does n represent again? Number of years after 2014. That's the important part. It doesn't represent the year. It represents the number of years after a certain point in time, being 2014. So, how many years after 2014 is the year 2030? 16 years. 2030 minus 2014 gives me 16 years. So, that's our value for n. And then we can go ahead and evaluate and solve for f of 16. Go ahead and work that out. F of 16 equals what? No, because it's the number of years after 2016.
Oh.
Or after 2014.
Oh.
Yeah. Think of it this way. 2014, n is 0. And so then we go for the numbers after that. 2015, n is 1. So they added in 8 more rows because n is 1. So what's f of 16? 9 what? 911. 911 rows.
Oh.
Okay. So we have 911 roads in the year 2030. Now, second question, same scenario. At this rate, which year will County X have at least 1,000 miles of paved road? Which year? So am I solving for f of n or am I solving for n? for N, because that represents my years, right? Years after 2014. So that means they have to give me something that represents F of N. What is that something? What does F of N mean? Number of roads. Number of miles. They want 1,000 miles. Okay? So now that we know what we're solving for and we have the rest of our equation filled in, go ahead and solve for N. Tell me what N equals. Do you know the value of N?
27. It's going to be minus 783.
Do I have TI-84 stamped on my forehead?
217 divided by 8 is 12.
27 point something. 5, something like that. Okay. So, in the year 27, I'll have 1,000 miles. Is that right? What does N mean again? What does N represent? After 2014. Okay. So, is my answer 27, or do I need to do something with that? We need to add it to 2014. We need to add it to the year because N is 27 years after 2014. So we need to add those in order to get the year. We can add the whole number year because it says in which year. So whether it's in January, February, or December, we're still going to be within that year. So we can just take 2014, add 27, and what year do we get? 2041. Right? Okay? I guarantee if this question was multiple choice on the SAT, 27 would be an answer option. Because you'll work it out, you'll solve for N, be like, 27, got it, boom, move on. But you gotta stop, you gotta pause, and ask yourself, does that answer make sense? They started building roads in 2014. Did they get more roads in the year just 27? Almost 2,000 years prior. No, it's ridiculous. Okay? So make sure your answer makes sense and see, hey, do I need to go another step further with it? 2017, Celeste's income tax was $2,290. Her income tax rate was 10% for the first $3,000 or $13,000, and then 15% for anything over that. Okay, so for whatever was left over after $13,000, she paid 15%. Okay, so the way that works, and this is how income tax brackets actually work. For the first part of money, okay, for the first $13,000 or whatever the bracket is that you make, they're going to take 10% of that, or whatever the income rate is. Then for any money you make over that, that's a different chunk of money. So say that you're making $20,000 total, okay? How much is in excess of $13,000? How much more money are you making above $13,000? Say again? 7,000. How'd you get 7,000? Just subtract. Yeah. 20,000 minus 13,000 gives you the excess. That 7,000 gets taxed at a different rate. So it's not the whole thing being taxed at the higher rate. It's just that extra money. And that's how the tax bracket works. It keeps building on top of that. So if you end up making $50 bajillion, then each step above that new set of money is what's getting taxed at whatever rate, not the entire thing. Okay? So that's what this is saying, and they want us to find out which of the following equations will model this scenario where we have one chunk of money being taxed at 10%, and then we have some other chunk of money being taxed at 15%. When you have these types of equations, it helps to kind of write out and verbalize what your model is talking about. Okay? So we have a 10% of 13,000. That's the first part. Every dollar she makes up until 13,000, we're going to take 10% of that. Then they're going to take 15% of anything over $13,000. Okay? Remind me again how we find the amount of anything over $13,000. What did we do to find the amount over 13,000? We subtracted, right? We did the total minus the 13,000. That's how we found that part, right? Anything over 13,000, we had to subtract the original 13,000 because we don't want to count it again. Okay, you don't want to get double taxed. So we separate that, and then what's left over is getting that new tax rate. And all of that together, the 10% of 13,000 and the 15% of whatever's left over has to equal the amount of income tax that she had. And if we take 10% of this amount of money, and we take 15% of this amount of money, and we want to get a total, what do we do with those two amounts? I want a total. What do we do with those two amounts? Add them. Add them together. So we know it's going to be an addition operation. Okay? So at this point, we should be able to just use process of elimination. Okay? The fact that it's an addition problem eliminates what? A and B. Because those are not addition problems. So it leaves me with C and D. Which one of these models, what we laid out here, 10% of 13,000, well, those are both the same. Okay, I've got 10% of 13,000. Which one of these represents, either here or here, taking 15% of what's left over? C or D? Which one?
C.
Does X represent what's left over? So how do I find what's left over? Subtraction. So is it 15% of her income? Because X is her total income. Or is it 15% of her total income minus $13,000? Minus the 13, right? We already taxed the 13,000. We want what's left over. So I need to take her total income, and subtract $13,000. So you need to separate the two parts of the equation. The first part of the tax and the second part of the tax. And reason through that process of how are we changing from one set to the next. So D is going to be our answer, our equation. And then we could use that equation to solve whatever questions we want. All right. Edit a manuscript. Miguel charges $50 for the first 2 hours and $20 per hour after the first 2 hours. Which of the following expresses the amount C in dollars? If that Miguel charges, if it takes him X hours to edit a manuscript where X has to be greater than 2. Okay? So which of those do you think models it? A, B, C, or D? It's $50 for the first 2 hours and then $20 for every hour after that.
C.
We have a flat fee. You hand Miguel a manuscript, he's going to say it's going to be at least $50. Okay, I charge that to everybody. No matter how long it takes me, You're going to be charged at least $50. Then, if I'm spending more than 2 hours working on it, I charge you an additional $20 per hour. So for every hour that passes after 2 hours, the price is increasing by another $20 over and over and over and over and over. So we've got our rate of change and we have our constant fee. Now what we're going to do is we're going to take this same equation and we're going to use it in our inequality. So we're going to rewrite this model. Cost is equal to $20 per hour plus $50 flat fee. But now we're going to expand on this scenario. How many hours does Miguel have to work to earn at least $300 on just a single job? Based on that sentence, two things are going to change about that model. What two things should we change?
Instead of being,
Why do you think it should be 100?
because, oh wait, no, I read it wrong.
Okay, because we want to figure out how much he's going to charge. That's what C represents. So we need to change that to 300 because that's the amount of money he wants to make. What else is going to change? We will solve for x, but I'm worried about the model first. We're going to fix the model, the equation. Okay, what's the equal sign going to change to? Greater than or equal to? Is it going to be that? That's greater than or equal to. You want it the other way? That way? Less than or equal to? Oh, that's getting you guys. Because that's the big trick. The model itself, 300, 220x, and 50, that's the easy part. They're not testing, can you solve that equation, because that's plenty of other stuff that does that. They want to make sure that you can take these key words, at least, no more than, at most, greater than, less than, and you can put in the correct inequality symbol so that you can interpret the solution or your options correctly. So, is it going to be less than or equal to or greater than or equal to?
Greater than or equal to, because he has to make at least 300.
Has to make at least 300. So what needs to be larger? The 300 or the amount of money he makes? This side needs to be bigger, right? So is it the less than or equal to sign or the greater than or equal to sign? If this side needs to be
300 has to be less than or equal to
300 has to be less than or equal to everything else.
Gotcha.
Okay? So that's that interpretation part. The 300, that's the minimum. That's the smallest amount that he wants to make. So that should be the smallest side of our expression, our equation, our inequality. Use the right vocabulary. The 300 needs to be the smallest part, and the amount that he actually makes should be larger. So now we have our new model. We solved that the same way we did all of our fluency. We get 250 when we subtract, and then when we divide, we get 12.5. Okay? So 12.5 has to be less than or equal to x. X needs to be greater than or equal to 12.5. So now, we've got a solution that x has to be greater than or equal to 12.5. Let's talk about, let's say we had some multiple choice. We have A, B, C, and D. And you have answer options 9, 10, or actually let's do 10, sorry, 10, 11, 12, 13. Well, 12.5 is not any of my answers. So what's the solution?
Round up.
Why is it? Don't necessarily round,
Because
because hold on, real quick. I just wanted to say this before I forget it. What if this wasn't 12.5? What if it was 12.4? If it was 12.4, I'd round it down to 12. Okay?
Because it says at least. Right?
Yeah, it has to be greater than 12.5. 10 is less than 12.5. 11 is less than 12.5. 12 is less than 12.5. It's really close to it, but it's still not greater than. 13 is the only one greater than. Okay? If we flip that inequality, well then our answers are going to change. 12 would work. If x had to be less than or equal to 12.5, then 12 would be a valid solution. So it's making sure you have the correct inequality symbol, you solve, and then you can interpret what the right answer should be from the options that are given. And it will say, which of the following values could be the number of hours Miguel could work to earn at least $300? And so you could figure out which one of those would cut it just by solving and then matching up your inequality with any of those. All right? Picking an equation or an inequality based on our scenario. Yeah, and kind of like with the earlier one, where we have the taxes, we have two different kind of rates going on. So convenience store requires Ayumi to spend $4 or more if she wants to pay using a debit card. That sentence alone will eliminate half of our options. Which two options can we toss out because of that statement? Why?
Because it doesn't have
Yeah. Well, it doesn't have the $4, the or equal to, right? Because it says $4 or more. So $4 is enough, or $4.01, or anything above that. So we can toss out that and that, because they don't have the or equal to that is required. So then we just need to kind of break it down. And you can kind of look at the equations and see what's happening and figure out which of these would match when we finish reading it. Okay, so in B, we're taking D, some variable, we're adding 1.2 and then multiplying it by 0.8. In the last option, we're only multiplying D by 1.8, and then we're adding 1.2 separate. Okay, that's the two differences. So when we finish reading, donuts cost 80 cents each. A bottle of orange juice costs $1.20. If D represents the number of donuts, so D is a variable. D is a variable that represents donuts. Okay? Variable means it changes. It represents donuts. And represents donuts. How many would she need to buy if she wants to buy her donuts and pay for one orange juice? So how many donuts and one orange juice? Okay? Is the orange juice variable or constant? Constant, because she's only buying one, right? So if orange juice is constant, that means it doesn't change, right? So that means the cost of an orange juice stays the same. So the cost of my orange juice is constant. Which of these equations has the cost of my orange juice being constant? D. And then it only has the price of donuts as variable. Okay, she'll purchase as many donuts as she needs to hit that $4 limit, but she's only ever going to purchase one orange juice. So D is our linear equation. Donuts will change, orange juice is only one. Alright. I'm going to be completely honest with this next one. I hate this question, mostly because the equation they chose to write. But, unfortunately, College Board won't hire me to write the questions, so we're stuck with what we got. Okay? It is what it is. This type of question, what it does is it's testing two things. One, inequalities, okay, that you can understand your inequality symbol and the information that's given. Alright? But also, it's going to be dealing with some rates. And we're going to spend more time working on rates in the second unit when we get to problem solving and data analysis. Okay? But for now, we can handle this. So Ngozi needs to send out 300 wedding invitations. In 1 minute, she can put 6 invitations into an envelope and apply stamps. And then it takes a minimum of 50 seconds to address each invitation by hand. If N represents the number of invitations Ngozi can prepare for mailing in 180 minutes, which of the following inequalities best models the situation? When you're dealing with rates, it needs to be in the same unit of time. The problem here is that they give us 1 minute and they also give us 50 seconds. So those are 2 different units. Okay? So we need to either convert it to minutes or convert it to seconds. All right? So let's think about the amount of time it takes to do each task. Okay? So in order to address one invitation, or sorry, not address one invitation, to put an invitation in an envelope and get a stamp, it takes 1 minute to do 6 of them. So how long does it take to do 1 of them? If it takes a minute to do 6, how long does it take to do just 1?
10 seconds.
Okay? So it takes 10 seconds. 10 seconds to stamp an envelope. 10 seconds to stamp. Okay? How many seconds in a minute?
60.
Okay? 10 seconds to stamp out of 60 seconds. If we simplify that fraction, what do we end up with? 1/6. So it's 1/6 of a minute. Okay? It's 1/6 of a minute to stamp an envelope. How long does it take for her to address the envelope? 50 seconds, right? 50 seconds to address. Out of the 60 seconds that are in a minute. If we simplify that fraction, what do we end up with? 5/6. So it takes 5/6 of a minute to address the envelope. So it takes a 1/6 of a minute to stamp it, and then a 5/6 of a minute to address it.
So it takes 1 minute to stamp.
Yeah, so it takes 1 minute per envelope to stamp and address it. So we're combining these things for that whole process. N represents the number of invitations she can prepare. So for every N invitation, that she does, it takes a 1/6 of a minute to stamp it, takes a 5/6 of a minute to address it, combined together, that's all the same thing. Okay? She's going to be spending 180 minutes addressing it. Okay? She's going to spend 180 minutes addressing it. So we have a couple things here that we can manipulate this equation to try and match it with one of these. All right? 2 of these we can get rid of right off the bat. Which ones do we think we can get rid of? C and D. Why C and D? Okay. 6 over 5 versus 5 over 6. Also, we have 6 instead of 1/6. Okay? So those aren't going to work. There's another reason why we can ignore C and D. The 300. That's going to be how many invitations she needs to send. That's what N is. N will end up being 300. Or N is just the number. So we're not comparing it to the number of invitations. We're dealing with time. So we've got 180 minutes. So she's going to spend more than or equal to 180 or just more than? Because that's the only other difference is the inequality symbol. She will be spending 180 minutes. Greater than or equal to or just greater than? Can she not spend 180 minutes? She has to spend more time than that? N represents the number of invitations she can prepare in 180 minutes. So she'll be spending at least 180 minutes. Maybe she'll get it done in that time. Maybe it'll take longer. But we need to include the equal to. Because this just adds up to 1. It's stupid. It's unnecessarily convoluted. I'm glad you think that.
I don't think it'd be very easy if he wasn't here to explain.
It's unnecessarily convoluted. It is. But also when we deal with unit rates a little bit more and we review those in the second section, it'll make a little bit more sense because you'll have that background as well. Okay. Alright, so that I think is the end of lesson 1. We'll pick up lesson 2 tomorrow. It's just 2 slides and then we'll be done with that. You can start